Okay, section 8.2, video, part 1. Sorry about that, I had to close my door. Okay, section 8.2, video, part 1. What I want to do in this section, in 8.1, we looked at solving, let me take this off now, they've left. Solving quadratic equations. And we've looked at, in 8.1, we looked at solving quadratic equations by the square root property. The problem with the square root property is it didn't solve all quadratic equations. Remember the square root property, it could only have a squared term and a constant term only. We also learned in section 5.8 another way to solve quadratic equations, and that was by factoring. So we've solved quadratic equations using two techniques, 5.8, the factoring method, 8.1, the square root property. The problem with both of those methods is they don't solve all quadratic equations. If you can't factor it, you can't use the method in 5.8. If it has a middle term, you can't use the method in 8.1, the square root property. Well, what we're going to look at in this section is we're going to look at a formula that solves all quadratic equations. Now you say, now wait a minute. If we have a method that solves all of them, then why do we even bother with the first two methods? Why bother with the factoring method and the square root property? And the reason is just simply this. The factoring method is just a lot quicker. It's a lot easier if you can use it. Same way with the square root property. But if I have one that can't be factored and I can't have one that can't use the square root property, I can always use the quadratic formula. Okay, so how do we use this quadratic formula? Okay, let me give you a couple of notes. Take this note down. Given any quadratic equation that is in standard form, we can solve it by the quadratic formula. We can solve it by the quadratic formula. All right, let me give you two things here. First, when I say standard form, remember the standard form for a quadratic equation is this. If you'll remember, I gave that back to you in 5.8. You may not remember that, but I did. Standard form just means put it in this order and set it equal to 0. Standard form for a quadratic equation has to be set to 0. And you want your x squared term first, your x term next, and then your constant term. Now remember, a quadratic equation, the only two things has to be present for it to be a quadratic equation. You have to have the x squared, and you have to have the equal sign. So b could be 0. That means you don't have an x term. C could be 0. Now, a can never be 0 in a quadratic equation, because if it is, you don't have an x squared. And if you don't have an x squared, it's not quadratic. So you have to have an x squared present, but you don't have to have these, though most of the time we do. So that's the standard form for a quadratic equation. Now, what is the quadratic formula? The quadratic formula, write this down. That's the quadratic formula. Okay. Now, let me show you this right here. You don't have to write this down right here, because we're going to do some in just a minute. But just watch. So every one of these are quadratic equations. So what we're going to do is first we're going to put it in standard form. This one's in standard form. This one is not because it's equal to 8. So we're going to move the 8 over. Now it's in standard form. This one is not in standard form because it's not equal 0. So we're going to bring these two terms back over to the other side. Now it's equal 0. So you got to put it in standard form first. Now, what do we do next? Well, if you will look right here at the standard form, now look at the quadratic formula. What letters do you see right here in the quadratic formula? A's, B's, and C. A's, B's, and C's. Well, there's an A, B, and a C in the standard form. So what does that tell me then? A is the number that's in front of x squared. B is the number that's in front of x. And C is the constant term. So, once we put it in standard form, A will be what's here, which is 1. B will be what's here, which is 3. C will be what's here, which is -7. Once it's in standard form, this is A, -1 is B, -8 is C. And once it's in standard form, A is 7, B is -3, C is -1. Now, if that number's not there, C would be 0. But you put it in standard form before you get your A, B, and C. Otherwise, your signs are going to be messed up. So it has to be in standard form. Then we're going to take those three numbers and plug it straight into that formula and work the problem. Okay, so here's what we're fixing to do. We're fixing to do 3 problems on the quadratic formula. All right, let me make sure you've got the whole thing in your view. Yes, okay. Pause the video now and copy this one. Okay, I'm going to go over that one in just a minute. Here's the second example. Solving by the quadratic formula. Pause the video now and copy this one. Okay. One more example I was wanting to do. Let me grab it right quick. I have it. I have it. Okay, well, let's just go back over those two first, and here it is right here, I'm sorry. Here's the third example. Okay, just a second, I'll tell you when to pause the video. Okay, pause the video now and copy this one. Okay, so you should have all 3 of them copied. Now let me go over them. All right, let's do this first one. First thing I want to show you about this first one right quick, you've just copied it down. See if you can see it over here. Slide it over. Okay, right here. I'm going to slide it a little bit more. Okay. Here's the original problem right here. It turns out this one could be solved by factoring. All right, so let's look at it. This is x squared. This is the easy case. X and x. Signs are the same, both plus. I need 2 numbers. When you multiply them, you get 4, but if you add them, you get 5. That's 4 and 1. But then you have to set both of them equal to 0 to get an answer of -4 and -1. Now, look at how much work that is. That's how we did this problem in 5.8. Now, you say, well, if it's easier to do it that way, why aren't we using the quadratic formula? I just want to show you that the quadratic formula will give you the same answer, but I also want you to see why we do it by factoring if I can. All right, so now let's do the quadratic formula on this. So the two answers is -4, -1. Okay, so first thing I do, I'll put it in standard form. It is, get A is 1, B is 5, C is 4. Now write down the quadratic formula. I would suggest that you write it down because the more times you write it, the easier it is to memorize. Now bring the negative down. B is 5. I would suggest that whenever you put the numbers in for A, B, and C, a good habit to get into is put them in parentheses. So this would be -5 plus or minus the square root of B is 5 again, squared, minus 4, that's always in the formula. A is 1, C is 4, all divided by 2 times A, which is 1. All right, now, do what's under the radical first. So you got -5, bring that down, plus or minus, 5 squared is 25, minus 4 times 1 is 4, 4 times 4 is 16, all over 2 times 1, which is 2. 25 minus 16, you have to subtract them first, is 9. And then the square root of 9 is 3. Now remember, all quadratic equations have 2 solutions. So, I'm going to break this into 2 parts. The top part would be -5 plus 3 all over 2. That's the first answer. The second answer would be -5 minus 3 all over 2. Now, what's -5 plus 3? -2 over 2, which is -1. What's -5 minus 3? -8 over 2, which is -4. So I got 2 answers, -1 and -4. Now look at the difference in this word as compared to this one. But I still got the same answer. Okay? Now, let's go over this one. First, put it in standard form. It is A is 1, B is 10, C is -7. Plug straight in. Negative B, which is 10, plus or minus 10 squared, minus 4 times 1 times -7, all over 2 times 1, because A is 1. Now, do what's under the radical first. So this would be -10 plus or minus. 10 squared is 10 times 10, which is 100. Then 4 times 1 times 7 is 28. But that negative times that negative made this go positive. So 100 plus 28 is 128. Now, you can either let your calculator reduce this for you, square root of 128, or you can reduce it yourself. If you break it up, 128 is 64 times 2, which reduces to 8 square root of 2. Or you can, again, use your calculator to do that. Now, if there is a number that goes into all 3 of these, you can reduce it. But it's got to go into all 3. Well, 2 will. 2 goes into 10, 5. 2 goes into that 8, 4. You don't touch what's under there. And then 2 into 2 is all over 1, which I don't have to put. So, this is 2 answers. Now, you could break it apart like we did a while ago, but there's no need in this case because if you break it apart and write it this way, you can't add or subtract those together anyway. I broke the other one up because you can add those together, but you can in this case. 2 answers. But you can't solve this one by factoring because there's no 2 numbers that multiply to give you 7 that subtract to give you 10. So this one is not factorable. So you can't solve this one by what we did in 5.8, and you can't solve it by what we did in 8.1 because it has a middle term. Okay, last example here. This problem right here. First, it's already in standard form because it's equal to 0. Now, it doesn't matter what side the zero's on, as long as everything's, as long as it's in the right order and equals 0. So A is 4, B is negative 12, C is 11. Write the formula down and plug the numbers straight into the formula. Double negatives gives you a positive. Negative 12 times negative 12 is 144. Then 4 times 4 times 11 is 176. All over 2 times 4, which is 8. If you subtract these, you get negative 32. And remember, when you have a negative under a square root, that means you're going to have an I in your answer. Now, you can't punch that in with your calculator. You can punch square root of 32 in, but you got to remember to do the I yourself. So if you take square root of 32, it's 4 square root of 2. Or this is how it's reduced if you're doing it yourself. But you can punch it into your calculator, you just can't put the negative under there. But remember to put your I. And then right here, 4 goes into every one of these. So divide by 4. So that takes that to a 3, that to a 1, and that to a 2. So that is called solving quadratic equations by the quadratic formula. And so that concludes this section.